To Data Innovation Summit 2019. You heard me last year, I'm here again, and I'm going to guide you through the rest of the day. This event is now bigger than ever. We have up towards 2,000 attendees, and the schedule is packed with interesting talks, with everything from super technical binarization of neural networks to ultra practical how to put your machine learning and analytics workloads into production. So I hope you'll stay with us the rest of the day and look at some of the super interesting panel debates, talks, and everything else that's going to be here live. So last year, one of the main themes was AI first. And I think this year we've tried to go with the motto, innovate through your data. And one of the reasons is that AI has started to become commodified. We're seeing that tools are becoming more mature. We're seeing that services are becoming available in the cloud that sort of automate the types of workloads that you really had to do manually last year and a couple of years ago. So now it's becoming really ready at hand, even for people that perhaps don't want to have to code everything manually. And it really puts companies in a position to not just talk about the AI ideas that they have, but to put it into production. The hosting solutions are enterprise ready. The ways to iterate and do continuous integration and everything else that's required is ready. So the machinery is very much in place, and now what's left is for companies to innovate and come up with clever ways on how to apply machine learning to their business reality. And I know a lot of companies have been struggling with this because it's not always clear how a CAT classifier applies to their supply chain or anything like that. But that's really where the hard work is going to be from now and forward, because the technical infrastructure, it might not be in place at every company, but the tools necessary for putting them in place are there. So the only thing left is to really sit around and rack your brains and doing brainstorming to come up with the use cases that can go into production today. Another topic that was pretty hot last year was GDPR. We had many panel debates here and people discussing how they thought GDPR was going to turn out, and we haven't really seen the fallout from that this year. GDPR has been in effect for quite a while now. The apocalyptic scenarios that many people imagined were going to happen never really panned out. We've seen a couple of cases where we could perhaps draw jurisprudence and see what you absolutely shouldn't do with respect to GDPR, but in many other respects it's still up in the air exactly what the effect of it is going to be. So I suppose what we can assume is that people are still taking care of, or at least have prepared for GDPR properly. But I guess the rest remains to be seen. Let's see, another topic. There are a lot of novel machine learning approaches to problem solving that have come out this year as well that are super interesting. And a lot of the nicest applications of machine learning haven't necessarily been new frameworks or new data structures on how the machine learning works, but rather clever approaches on how to structure the data, which ties back a little bit into what you as a company need to be thinking about to be taking advantage of these new technologies. One of the examples that I really like to give to people is, this year I saw a team come up with a model that can solve Rubiks Cubes. And the challenge with a Rubiks Cube, if you've ever tried to solve one, is when you have a Rubik's Cube that's fully solved, if somebody were to hand it to you and turn it one space, it would be fairly obvious for you how to turn it back and solve it. But if you have a Rubik's Cube that's completely jumbled and you turn it one step, it's not entirely clear whether that was a good move or not. So how do you train a machine learning algorithm that does moves like this to know whether it did a good move or not? And the solution the team came up with was to make a model that could start by solving a cube that was only jumbled one step. So you start with a solved cube, you jumble it one step, and then you ask the machine to solve it. Once you have a model trained for that, you jumble it two steps, and you ask the machine to solve it. And so on, until the machine can solve one that's arbitrarily jumbled. Now the cool thing about that was that the machine learning model and data structure that they used wasn't particularly exotic, so to speak, but the method that they applied to solving this particular problem was pretty clever, I think. I think you could call it a cool hack. And I think those are the types of innovations that companies need to be looking at. So you have your team of super clever data scientists, they can implement things into machine learning, and what you need to be thinking about is, how can we be clever at applying our data to machine learning, analysis, streaming, data surfacing, and all these things. The infrastructure is in place. Now it's up to you to be creative and innovative. I think I'm going to wrap up now a little bit. We are going to be heading over very soon to the main stage, where we're going to be having a keynote with Henrik Göthberg, also someone that's been with us for a long time. Let's see, he's going to be talking about, this is the main stage, the plenum, here we go. Yeah, well, it's the opening remarks. I think he'll be wrapping things up a little bit like I've been doing now. I will be back in the Data Octagon very soon with super interesting panels. Stay tuned, and I will be seeing you later on today.